A big part of proofs is form. We saw this in those continuity questions in the previous unit. Form really, really matters. The introduction statements have to be there. They have to be correct. They have to have every part of them. The setup has to be correct. The steps obviously have to be correct. And then your final statement obviously has to be correct. And that's how you can think of them. There's like an introduction. Then there's like you're defining things in your setup. Then the work. Then your summary. Okay? So for constant function, we're talking f at x equals k, where k is some constant and k is an element of the real numbers. And the way these proofs work is we go back and we do it from scratch. Like we didn't prove any of those things before. In fact, I usually make a little note in the sum thing in the lesson that what we did wasn't a proof. We haven't proven the sum rule yet. I just told you that's what it was, but we will prove it. Okay? By inspection, we noticed that if it's a constant function, the derivative is going to be 0, right? Because just by thinking about the slope of that line. But we haven't proven it algebraically. So we always have our opening sort of defining our variables and introducing the actual question. Then we have our setup, which is the H formula. And you have to use the H formula, not the x minus a formula for these proofs, okay? So, and you always start with this. For every proof, you'll notice we start with this. And I'm missing something in mine. Whoops. F prime, sorry, because you will probably have a hard time. The limit as h approaches 0, that's kind of an important part, right? Sorry about that. Now, I sub in the function equals the limit as h approaches 0. Well, if f at x is k, what's f at x plus h? K, right? Because if it was f at x equals x squared, it'd be x plus h squared. You'd sub x plus h in for x. But if f at x equals k, there is no x to sub into. So the x plus h doesn't go anywhere. So f at x plus h is k. F at x is k over h. Do you see how this works? Well, that's what I just said. So that's okay. If it was f at x equals x plus 7, then f at x plus h would be x plus h plus 7. But if it's f at x equals 7, then what's f at x plus h? 7. There's nothing to sub into, so it doesn't matter where you're evaluating it, right? Yeah. And does anybody know what k minus k is? 0. So this one's already done. But again, we don't ask this one on a test. If you find yourself doing this one as a proof on a test, what you're doing is wrong. Stop doing it and do the proper one, which would be constant multiple. Okay, but that's how these proofs work. So it's an easy one to see as your first one. Then we say, therefore, if f at x equals k, where k is a constant, then f prime at x equals 0. Yep.
Isn't it 0 over 0 if you're subbing 0 for h?
Because 0 over h is just 0. So I haven't subbed in yet until I simplify. Okay. Right? I simplified 0 over h to 0, and now there's no h left. Okay. Good question.